So you see right now I have this Tupperware filled with water and filled with sediment. You can see sediment on here, and it is to model a creek when there is no waves or any flow going. The sediment sinks to the bottom, and you get, water that has a little bit of dirt color, but it's mostly going to the bottom, and you can see the water on the top. And I put this little model together because I wanted to discuss what scour is. Scour is, or at least hydrodynamic scour, is the removal of sediment such as sand or silt from around objects which disturb the flow, causes high velocities of water, and that can remove sediment particles and leave a local depression. So that's the very official definition. And what it really means is that when this pretend creek then sees a very strong rain, here's what happens. I'm going to take this wooden spoon. I'm going to stir, and you can see all the silt. So when it rains, it kicks up all the sediment. You no longer see it on the bottom. All that stuff is rushing around, and when it's rushing around at a high velocity, then it accelerates that local depression that gets created. And you know what a scouring pad is. So here's a scouring pad, and you know how you scrub dishes with it. It's like scour in a creek is like having, the soil is like having a scouring pad that will scrub away something that keeps something in place. An example would be a tree. If you've seen scour in a creek, you'll see all the tree roots exposed. Scour around a sewer pipe that's in a creek can pull away all that soil around it, and all the stability holding up the pipe will go away, and then that can cause a leak, crack, which then dumps sewage into the creek. So we want to try to minimize scour as much as we can. And but if you don't know what scour is, it's hard to understand why it's so important. So this is scour in a nutshell.